I'll collect the homework. If you did poorly on the two-step equation, it kind of doesn't make too much sense to ask too many questions, because they all turn into two-step equations. So if you can't solve two-step equations, we got big problems, big problems. All right, we just took our quiz. We have a week until the test. We are moving away from solving equations to solving inequalities. All of next week, we're going to be doing inequalities from 5.6a all the way through 5.7. Today's the last day of equations. So if what you just took on your quiz, you bombed it, I expect to see you, right? We got to fix this mistake, right? The test will be on more than just two-step equations. It will be on multiple steps. Yes? I can't hear what you're saying. You don't need your math book. Yes?
Why did you go 5, 9, and then 5,
I explained it yesterday. Were you paying attention?
No, not really.
I said that 5, 9 is a two-step word problem. I said I would much rather do it right after I teach you solving equations than to wait to the very end and then jump to, oh, by the way, for the last 4 days, we've been doing inequalities, then we jump back to equality. So I choose to teach it right after we do solving equations. Hey, this does not say written exercises. What does it say? Class exercises. So on page 171, 2 through 8 evens, class exercises. 170.
So this right here,
where it says class exercise. Yes. Yes. All right, here we go. 5, please. So it says translating problems into equations is word problems involving 2 steps. Okay. As always, when I do a class on word problems, I can't do enough to make you feel comfortable ever. I can do a few. I try to pick a few for examples that are like the ones for homework, but I can't make them all look like the ones for homework. All right, word problems. All right, if you need I don't know, a step or a procedure to solve word problems, this is my suggestion. Box 1, write this down. I want you to read the problem. And by read, I don't mean you just skim it over. You're going to read it. You're going to read it carefully. You're going to read it closely. Some people like to underline. Some people like to circle. Some people like to write notes. When I read, I always look for the question mark. There aren't always a question mark, but most of the time there is. The question mark will tell you what you need to do. Find how many days there are in 6 months. Okay, I know what to do now. There's not a question mark there. How many cars are needed to do this trip? All right, there's a question mark there. Draw a picture for me is always one of the primary things, and I always put it as a requirement in the sense of if a picture helps. Sometimes you can understand it without drawing a picture, but most of the time drawing a picture is necessary. But there are a couple times. You're not going to see me draw too many pictures today. These are pretty simple ones. Today, you're going to be setting up an equation and solving it. We'll start off a really easy one at first, and then it'll jump quickly to 2-step equations. So there's not going to be a multiple-step equations. And like I said, I tried to pick some examples. They're like the ones I'm going to ask you to do for homework. Once you set up the equation, you're going to solve it for the variable, right? And then, well, because we're doing math, just because you got x equals 10, if it says, you know, I don't know, how many hands does this person have, and you get to an answer of 10, Clearly, people don't have 10 hands, so check to see if it's a reasonable answer. That is the hardest part of it. So we'll do a couple with just a one-step equation. This is as easy as it gets, as easy as it gets. Kai and Jackson, please pay attention. There's a lot of words there, and I will say that a lot of kids get hung up by this particular one because it's got a lot of words and there's some things you do and don't understand. This is a very, very simple problem here, but boy, do they make it sound complicated. Read along silently while I read. Electricity usage is measured in kilowatt hours, kW times H, kilowatt times hours. That's a kilowatt hour. Okay. A water heater is estimated to use 4,219 kilowatt hours of electricity in a year. Well, how many is that per day? There's a lot of words there. There's certainly, most of you aren't familiar with kilowatt hours for sure, for certain. This problem is only about a simple division problem, right? Or multiplication if you want to think about the inverse. It just says how many of these hours or how many watts did you use per day in a year, right? Well, it tells me how many I used in a year. How many did you use in a year? 4,000.
4,219.
So it says how many is that per day?
That divided by 5.
Yeah, I'm just saying. So this is an example of a very seemingly complicated issue when in fact it's just a number divided by 365. Now, if we follow the procedures, if you weren't aware of that, if you did not get that from the problem, then we got to set up an equation, right? Let's say that you eat 2 apples a day. If we were to write an equation for how many apples you eat in a year, what would that equation be? So it would be the number of days, in this case 365, times how many apples you eat a day equals whatever that number is. The difference here is they tell us what that number is. We're not apples here, we're kilowatt hours, right? So I would take the number of things that you use per day, times it by 365, and that's going to equal, well, in this case, it's going to equal that number right there, okay? The issue here is this kilowatt hours just confuses the heck out of some people. Don't let it confuse you. What?
It shouldn't confuse us. We're taking.
Oh, I agree, but I'm just saying this one, I used to assign this one, but this was the one that caused people problems. It's because of this right here. They look at this. It's a formula. Kilowatts times hours. It is a formula, but it's not really part of our problem here. Our problem just simply says, well, how many kilowatt hours are you using per day? So if we plug in what we know 4219, we know the days are in a year. Okay, so what I don't know are kilowatt hours per day, which would be my X. So it would be times 365 equals that. Okay, solve that equation. What do we do?
Divide.
Both sides by? And that's what we're going to get. So there's your equation. We divide both sides by 365, we get to an answer. Ugly math, but the actual operation of what to do isn't that bad. This skill of being able to read sentences and translate it into an equation is challenging for everyone included. There are no math people out there that say, wow, I just wish I could have 40 word problems, because they're the best, right? Word problems are challenging. All right, there's your first one. By the way, anybody got an answer?
11.55. It's like it's
So 11 kilowatt hours per day, right?
yeah.
Okay, that's cool. Remember, whenever you round, you can't put an equal sign. You got to put the approximation symbol. All right, so that's that one. I just get that one out of the way. Let's do one that you can solve, all of you. So once again, this is box 3. Read while I read out loud. A delivery truck is carrying 8,713 pounds of pet food. That's a lot of pet food. At a weigh station. You know what a weigh station is? You guys going to, you know, when you drive up to Denver and you pass Palmer Divide, on to the right there, they got this thing, and there's all these trucks pulled over to the side of the road.
Yeah.
That's a weigh station, right? And it literally says weigh station. They literally do what there? Why in the world would they want to weigh the trucks? Right, so they get taxed on, you know, how much weight they carry. So if they're overweight, then they're not allowed to drive on the road. and because it does do damage to the roads and whatnot, and bridges, obviously. A delivery truck is carrying 8,713 pounds of pet food. At a weigh station, the loaded truck weighs 17,000 pounds. What is the weight of an empty truck? How in the world am I going to figure that out?
Subtraction.
You see what I mean? Some of you got that immediately, and the rest of us are like, well, what the heck does this problem even mean? It's just a simple subtraction problem, right? So if we were to set up variables, we'd have a variable for the truck weight, right? We'd have a variable for the food weight, and together, added together, that equals, in this problem, what? Today, that equals 17,000 pounds. So of these three things, well, I know the total weight. I also know the weight of the food, right? What I don't know is the weight of the truck. That's my variable. Now, what you guys said immediately, it's subtraction. Guess why you said subtraction? Because guess what happens when you solve this equation? What are you doing? You're subtracting. So once again, this is just a one-step equation. How do we get x by itself? We subtract 8713 from both sides. Anybody got the answer? What do you got?
8,293.
I got 8,000.
What? Monkeys?
Pounds.
Pounds. I got 8287 is what I got. Yes?
That's what
Okay. It should be LBS, not LB. Plural. Cool? All right. What was our quiz on? So we better do a couple two-step equations. So the one-step equations, I will just say most people can literally just read it and kind of figure out what's going on. Two-step equations, no way. No way, Jose. You got to set up an equation. So we better pay attention for this one. Box 4. It says that Harry Potter, no, it just says Harry. Harry spent his birthday money on flying lessons. Not with a broom, though. Mel spent 75 more bucks than Harry. Together they spent 143. How much, and they're talking about money, did Harry get for his birthday? Okay, so this is a tough one. The way that you make it easy is you draw a picture and make sure you understand what's going on. So what's the first thing that happens here? What's the first thing that happens? Well, where did he get the money from? So what's the first thing that happened? He got money for his birthday. Do we know how much? So guess what our first variable is going to be? X, and X is going to represent how much he got. Okay, so I'm going to draw a picture. So we got Harry. He gets some money. Who else do we have here? We got Mel. And together they spend, right? So together, that means added together, right? They spend 143 bucks. But I don't know how much money Harry got for his birthday. So I put, okay, or X, right? Question mark, right? What does it say about Mel, though?
75 more than
So if Harry got X, how much did Mel get?
75 more.
So how do I write that mathematically? Not plus 75, not minus 75.
X plus
If he has this pile and he has 75 more than this pile, how big is his pile?
X plus 75.
X plus 75, right? That's usually, and that's done so many times. Does that make sense? Because most people just want to write plus 75, but it says not he got 75, 75 more than Harry. And together this is supposed to add up to, well, this is a two-step equation. What is X plus X?
2X.
Could you solve that?
Yeah.
I hope so, because it was a quiz question. What's the first thing we do?
Subtract 75 from both sides.
All right, I'm going to go slower so everybody can catch up. So we subtract 75 from both sides. We get 160 something. Is it 68? Is that right? Therefore, how much money did Harry get for his birthday?
34.
How much did he get?
34.
Looks like Harry didn't spend much money on flying lessons, but Mel spent over $100. Hey, be careful with this because this question easily could have said, what?
How much the base?
What else could it have
How
said?
much did Harry spend?
Well, we got, that would be a bit more challenging, but another way of saying we could have asked that as well too is how much did Mel spend, right? So you have to do 34 plus 75, right?
What? That is silly for flying lessons are way more.
They're way more expensive. Guess how old our book is?
Old.
It's
too.
old.
Oh,
I took flying lessons in 1992 and 1993, and I spent $2,000 to get my license. And if I remember right, it was $75 an hour for flying lessons. And you have to take 40 so odd hours. You're like, well, that doesn't add up to 2,000. Yeah, because some of those hours you fly all by yourself, so it doesn't work that way. But it was $75 or so, depending upon the airplane that you chose to fly. You fly a bigger one or more powerful one, it costs more money. You fly the cheapest one, which is what I chose to.
I was lucky enough to have one of my grandfather's friends.
Flying is fun. I enjoyed it. And then I realized I was spending $75 an hour doing something. I was like, I got to get a cheaper hobby. Yeah.
So it says do not solve on the homework.
It
So
says do not solve. You're going to solve them all tonight for homework. All right. Next example. We good?
Yep.
All right. Jerry. So we got Harry and Jerry. All right.
Harry Jerry.
Jerry bought some plants for $2.49 each. Her total bill after deducting a $10 coupon was $23.90. How many plants did she buy? So a seemingly impossible thing to do. Wait, I don't know. If we set it up algebraically, it ends up being the easy one. So for those of you that struggle with this, I'd ask you technique number 2, make a simpler problem. In other words, envision what's going on in your head and try to draw a picture of that. So she goes to a store and does what?
She buys plants.
How many plants does she buy?
X.
I don't know how many, but I do know that she buys a number of plants. Okay, but then it says they cost $2.49 each. So what am I going to do with that? Multiply by the number of plants, right? So times that. When I put a multiplication symbol, I do, right? But then it says you go to the cash register and what happens?
You have a coupon.
A coupon. Does a coupon add money or take money away?
Take money away.
So what do you want me to write? Subtract 10, right? Where's my subtract 10? Oh, I did it the opposite way. All right. We would probably say subtract 10 on this side. I chose to add the 10 on that side.
Doesn't matter the way you do it.
Doesn't matter the way you do it. I guess intuitively, I should change this for next year. It should be minus 10 on that side because that makes more sense intuitively. All right, so let's see. X represents the number of plants, 249. Add 10, or subtract 10 on the other side. Right? Yes?
Yes. Yeah.
Okay. And then we got some ugly. Oh wait, that's not so ugly. Look, the numbers are the same, sort of, kind of decimals. See it?
Yeah.
Math teachers love to do this.
Yeah. Mistake.
Where?
It says plus 10 and you did plus 1.
It's on the other side though.
I did absolutely do that, didn't I? Thank you.
Plus 2.
That's crazy.
You mean what?
All right, these are not the droids you're looking for. Right. Let's do it by hand. So we got 2.49 is equal to
24.9.
33.9. Yes?
Sure.
I'll have to change this for next year because now the math isn't friendly. I mean, I made those numbers up because I wanted them to be nice and friendly.
You get 13.6.
Oh, no. But when the numbers were the same, then it's just moving a decimal place. It was a friendly number the way I did it. Now they're not friendly. All right. No, that's a format. All right, you get the idea? All right, how many we got left? So guess what I want you to do now? All right, I usually, when I do this, I have a lot of time left over in class, and I can walk around and give you assistance so that you're confident. So if the only thing you do is set up the equation, and then you can solve it by yourself. But try to at least do that. So how many problems did I give you? 4. We got a lot of time left. So if you didn't bring your book, scoot next to someone who has a book. Let's get this done. Yeah. Yep.
That much have a garage.
And a car wash.
Yeah. The amount raised the car wash.
So we got 2 things. So me, I'm gonna draw a picture, right? I'm gonna put, what's the first thing? Garage. So GS plus or minus CW. Okay, so GS plus CW, car wash, right? Equals, yeah. But there's one other extra statement here. What does it say? The amount raised at the car wash was raised at the garage sale. So if garage sale is X, the amount of car wash is half of that, and that would be written as, you're not gonna like this one. How do you say half? Or just divided by 2. So if it was X is the amount of the first plus,
one half.
oh, right? Now you could have said also 1/2 times X, either one's fine.
And it would equal.
And it would equal.
Oh,
Right. So it's an ugly fraction.
it's not that ugly.
Yes.
I got a single problem.
I mean, I thought they solved that.
$1. That equals, what was it? 0.12, something 36, something like that. Well, I need to turn this one now into a. It says how much is spend. So how do you turn 1 into a 75?
I do fail.
And so whenever you do to one side, you must do. So what are you really doing here? Both sides are 75.
So you that's like 3 years and nobody caught that?
Nope. Homework before you leave. Make sure your homework lines up in the box. That will be at the door. That Jaden will be holding.
Where do I go?
Make sure it winds up in the box. All right, e-learners, hopefully you see that one mistake right there and you're not confused by it. So that should be 33.9, not 24.9.
Bye, Donovan.